Hello everybody, this is Rudra Pradhan here. Welcome to Engineering Econometrics. Today we will continue with time series modeling, and that too we will discuss some kinds of time series models with a specific focus on again forecasting. So, let us see what are these items which we have discussed earlier. Technically, we have here detailed classifications and that too about the forecasting techniques. So, we have three groups, or we can say that it is a set of three baskets. The first basket is with respect to qualitative models, the second basket is the causal methods, then the third basket is the time series methods. In the qualitative models, we have Delphi technique, then a jury of executive opinion, Salesforce composite and consumer market survey. And in the case of causal methods, simple regression analysis and multiple regression analysis. And on the other sides, in the time series basket, we have net moving average, weighted moving average, exponential smoothing techniques, trend analysis, seasonality analysis, and then multivariate decomposition. In fact, some of the techniques which we have already discussed, for instance, causal methods we mostly discussed, that to simple regression structure and then multiple regression structure, and some of the qualitative models which we have highlighted. Of course, we have not discussed in details, because for the qualitative models we need inputs from the primary survey, and on the basis of that opinions we have to derive some kind of information, and that information can be used for kind of predictions and the kind of forecasting and as per the particular requirement of any engineering econometrics. But we will mostly focus those models where we have actually data, then with the help of techniques we can have the estimated model, and then on the basis of estimated model we can go for some kind of forecasting. In fact, in the time series models, whatever we have discussed earlier, we have gone through some kind of moving average techniques, and that to simple moving average, then 3 years moving average, 5 years moving average, and again we have also discussed the least squares mechanisms, that is the structure called as trend analysis, through which you can derive a kind of models, and that model can be used for the predictions and the kind of decision making process. So, let us see how is this particular structure. In fact, we have already discussed in the time series models. So, we have time series components starts with T trend, then C stands for business cycle, S stands for seasonal variations, and then there is a error terms. Of course, there is a additive structures and then multiplicative structure in any context. So, these are the various factors through which actually we like to generalize the prediction rules and the kind of forecasting rule, and then we have to go about this particular structure. In the time series stationary models, we have some kind of stationary model assumptions. Assumes item forecasted will stay steady over time, and then constant mean random variation, then techniques will smooth out short term irregularities, and forecast for period t plus 1 is equal to forecast for period of t plus k. So, that means the kind of structures which you like to bring, so that the process can be generalized and then we can develop a system through which you can do the predictions and the kind of forecasting. So, ternary model types, if you look, then we have net forecast, moving average, weighted moving average, and then exponential smoothing. Of course, we have already discussed slightly on these techniques, still we will just highlight once again. And in these lectures, most important is the focus on the error part. That means, technically by using a particular methods like simple average or kind of moving average, weighted average. So, we will get estimated a kind of models, that too if say y is a kind of actual variables, then we will have estimated y, and the difference by default will have a error. And again there are various ways you can find couple of alternatives, and one way to choose the best models to do the forecasting or the kind of predictions is the what we will call as the kind of error part, and then the error part has its actually kind of unique kind of characters. Every times when there is a kind of comparisons, and then the issue is to find out the best out of several alternatives. So, we have to apply these techniques through which actually we can actually pick up the best one. And whatever tools we will discuss here right now, like mean error, mean sum errors. So, like that there are couple of indicators are there. Every time, since it is a error component, every time the choice of a particular model for the prediction and forecasting exclusively depends upon the items which are actually minimum as per the particular requirement. So, the model is start with like this, f t is the kind of quarterly data, and then it is kind of integrated with the previous kind of items, that means through historical data. Technically we call as kind of lag variables. So, y t is a current variables at a particular point of time, then by default the t minus 1, t minus 2 is the previous variables, and that is what lag variable 1, lag variable 2 and so on. So, we like to integrate all these variables while predicting the current variables. So, now technically we have couple of indicators here through which we can actually choose the best one out of several alternatives. The first one is the bias, that is what is the mean error, which is actually means the difference between true value and the predicted value. Of course, the predicted value is derived from a particular process, maybe simple average, again maybe moving average, and that to 3 years moving or 5 years moving. So, whatever for maybe. So, our idea is let us have the predicted structure, and we have the actual structure, then the difference will have the component called as a forecast error. So, now dividing the time, then we will have actually mean, and that mean error should be actually should be used as a criteria to choose the best one, right. Similarly, mean absolute deviations, where we like to actually go for deviation format. So, that means usually when you find out the error term, which is the difference between the actual and the estimated, sometimes the error for the error component, that to forecasting error positive, and sometimes it is negative. So, when you take the modulus, then all the components will be coming as a positive, and again, so that will be the minimum criteria through which you choose the particular model. So, it is actually another structure called as a mean square error, and again so we have a root mean square error. So, again forecasting error is having actually some positive values and some negative values, and when we sum up, then there is a high chance that the sum will be equal to 0. That is how the particular line is called as best fit line. So, now one way to again use this criteria is to find out the square, and that is how it is called as mean square errors. So, now if you square all these errors plus and minus, then all will be transferred into a positive quantity. Then after that the criteria of choosing the best one is the minimum of MSE. Similarly, in the root mean square, so that is the square root of this mean square error. So, technically there is no big difference, and again there is a mean absolute percentage error. So, it is again same like mean absolute deviation. The same way you have to just divide the actual and then multiply by 100. So, we will get mean absolute percentage error, and that is the criteria through which you can actually generalize the kind of items through which actually we can predict the a particular requirement. Now, what we can do? So, we like to check all these kind of tools to predict, to find out the best ones out of various alternatives. So, let us start with a simple problem. So, this is actually monthly data, and let us say one monthly data of a particular year. So, starting with January 10, then February 12, like that up to December 19, and we like to start with NAV forecastings, and so the actual and then the NAV forecasting will be here just one point ahead. Okay. So, this is how the kind of structure. So, through which actually you can actually find out the this is what the estimated structures just 1 point behind. So, that means the actual is depends upon the past one, and then the error will be the difference between the actual and the past one. So, we will find the error component this one. Of course, the sum of the error terms should be close to 0, and here something coming actually 0.82 because of some round up issue, otherwise it should be converse to 0. And then if you take the absolute value, so it is coming 3, and then if you go by percentage error, just divide by y actual, then multiply by 100. So, you will get actually mean absolute percentage error. Then again you have the error, square the error and find out the sum. So, that is called as a mean square error again. So, take the square root. So, you will get root mean square error. So, that means technically for one model. So, once you find out the estimated model, you can find out the error, and then you can check the model accuracy by using the mean error, mean absolute deviation, mean square error, root mean square error, and mean absolute percentage error. Of course, they will give some value, there is no doubt about it, but the actual fact is that, so you need actually at least 2 different alternative models. Then the best models which you can choose from these 2 on the basis of these criteria, that is the mean error, mean square error, root mean square error, mean absolute deviation, and mean absolute percentage error. Every time between the 2 models where these errors are actually low compared to the previous one, and that model can be used as indicator for the prediction and forecasting, and that is what the benchmark through which you have to follow and go ahead with the kind of predictions. Right. So, this is what the kind of structure, and we will go with this particular setup to know how we can actually proceed. Okay. So, this is what the case, and we have here actually some kind of plotting. So, the a red one is the predicted kind of things, that is the NAV forecasting, and then the black one is the kind of actual actual one. So, now on the basis of this we have to find out the difference, and you will find sometimes the actual overtakes the predicted, and sometimes the expected overtakes the actual. As a result, you will find some positive error and some negative error. That is why we have different indicators through which you can actually find out the best ones. Okay. So, then there is a structure called as moving average methods, and which we have already discussed, and here you have to choose a particular moving average mechanism, maybe 3 years, then the 5 years, 7 years and so on. But ultimately with actual information we must have predicted information. What criteria use, that is not the big deal, but the deal is that you must have the actual information and the estimated information. So, once we can find out the estimated one, then we can find out the error term, and as a result we are in a position to use these indicators, and that too for the requirement of choosing the best one as per any engineering problems or as per the particular requirement. So, what we can do here, so we can actually check how the moving average is all about, and this is again the same data set, monthly data set for a year from January to December, and here we are using 3 years moving average mechanism. So, just first what we can do here. So, in fact, we have already discussed this one, and so this is the first 3, if it is 3 years moving average, then you find out the average, again next 3, so you will find out the average. So, like that you will find see here, so this 10, 12, 16, then 12, 16, 13, then 16, 13, 17, every time just in a kind of order. So, you have to just find out the average of 3 items, then as a result this will be your forecasted figures, and by default you have the actual figures here, and the difference between these two will give you the error components. Again, once you find the error component, you can go go for calculating mean error, mean square error, root mean square error, and then you find out the best one on the basis of these actually components. So, this is what the moving average mechanism, and likewise we can go for go for this error component. So, that means whatever we have discussed earlier, the same things we are here putting the actual value, then the forecasted value, then we will find the error, and then you will find different indicators by absolute error, by square errors, absolute error in percentage. So, these are all again the similar kind of indicators you can calculate, and again so for the best is required. So, you must have some alternatives. So, against the graphically the comparison is here, the actual versus the predicted, and again as usual there is a difference between the actual and the predicted, and of course, the predicted will be the good one if the error component will be converged to 0 in the first instance. So, that is what the kind of structure, and again while doing this kind of structuring, restructuring. So, we will pass through a structure called as stability versus responsiveness. So, we like to check the stability part, that means technically if the model is actually good with a particular criteria, say mean error, then obviously to ensure the stability, to say that this is actually good ones for the predictions as per the requirement. So, you can use simultaneously the other indicators like mean square error, root mean square error, mean absolute percentage. Then you finally say that yes, that is the model through which you can go for the prediction and the kind of management requirement or the kind of engineering requirement. So, this is another way of going through the finding the average estimated line. So, that is through weighted average, and here actually weight is with respect to different variables, and that too log of this existing variables. See here. So, it is the game of y t w1s, then w 2 y t minus 1, w 3 y t minus 2, and w n y t minus 1s, and sum of the w equal to 1. So, that means technically the weight w 1, w 2, w 3 will be in between 0 to 1. So, some points like 0 0.1, 0 0.3, 0 0.5, something like that, but the requirement is that sum of these weights should be exactly equal to 1. Then in fact, here we have two different package. The first package is that you can go for equal weightage principle, and the other one you can go for unequal weightage principle. Equal weightage principle means if there are say 3 variables, then by default 1 by 3, 1 by 3, 1 by 3. which does not actually give very high impact, but if you go for unequal weight, then it may give better indication and better kind of structure to pick up at the things and as per the requirement. But the problem is that how to ensure the unequal weights. If it is equal weight, then depending upon the number of variables, so just divide the numbers. For instance, if there are 3 variables in the right side, divide by 3. So, if it is a 5 variables case, then 1 divided by 5. So, 1 by 5 will be used for every weights. So, that means technically W1, W2, W3, W4, W5 is equal to simply 1 by 5. Now, if it is unequal weight, then what we are supposed to do? There are various mechanisms through which you can bring that weight, maybe the qualitative structure like Delphi technique or some experts opinion through which we can actually assign the weight factors, which may reliable, may not reliable, but mechanically there is a method through which you can justify, and that is more practical and more reliable. That is what the structure called as using factor analysis, and specifically using PCA, principal component analysis, you can derive these weights which are not necessarily actually as per the equal weightage. So, you will find difference of weights, and then corresponding to the particular variable you can assign weight there. So, it is actually mechanically you will receive these weights through these data and variables, and which may not have any questions or the kind of issues, but when you will go for equal weights, then there is issue, and means what are the basis you are putting actually equal weight, because the impact of log 1 variables may not be necessarily equal to the impact of log 2 variables. So, as a result the different log variables may have a different weights. So, assigning different weight is the better choice than the uniform weights. So, in any case we have 2 different mechanisms through which you can proceed and get the estimated model, then do the kind of comparison to pick up the best one as per the particular engineering requirement. So, this is what the process, and then we can actually look for another alternative method. See here, you see here the weights and which are actually unequal. So, of course, the idea is how to get these weights which you can actually have from the experts opinions or something like that, you can say on the basis of principal component analysis. So, that means technically it is not the big deal again. So, the same 3 years moving average. So, now instead of just adding 10, 12, 16, so you have to just multiply 10 into 0.22 and then 12 into 0.59 plus 16 in 0.19, then you get the average. Similarly, you have to follow every steps, and then you will have ultimately end of the day the predicted values, and here we have the actual value. The difference by default will give you the error component. So, that means it is a more or less actually same structure, just you have to follow little bit kind of different setups through which actually you can get these results, and that may be the good one compared to the previous one. That is why we need actually the kind of robustness structure and stability structure, where different methods we are applying and then checking that the results are uniquely actually a deciding factor through which you can do the forecasting as per the particular requirement. Then there is a time series models, exponential smoothing, and here the same structure we use log variables, and again so the same weight like we have discussed here, and then here alpha is a weight factor, then by default 1 minus alpha is the another weight factor. Since the sum of the weights are actually equal to 1. So, if you find weight of a particular factor by some clue, then by default if it is a 2 variable case, the other one will be 1 minus alpha. But if it is actually more than 2 variables, then this criteria may not be very easy to apply. But in that case, if you have more number of variables, so the best idea is actually to use PC and have the weights and then do the kind of estimations and the kind of forecasting as per the particular requirement. Okay. So, this is what the process. and then you can find out the see here in the exponential smoothing. So, you have the actual variables here and then this predicted variables y t minus 1 and then alpha of y t minus 1, and so that the weight can be use this is for the alpha y t minus 1 and 1 minus alpha y t minus 1. So, this is how you have to actually just that means this plus this is the weighted component and this is the single one. Then finally, we have the estimated coefficient and the kind of estimated equations, and then we have a actual y and the estimated y. Again we will find the error and check whether the error is actually maintain the stability by deploying different methods like mean error, mean square error, root mean square error, and so on. So, these are all various techniques through which actually you do the kind of structuring, restructuring, get the estimated value, do the predictions, check the reliability, check the validity, check the stability, then finally, you pick up the good one which can be really useful for the particular engineering requirement. Again, so every time you can in a tabular format you can check the kind of stability and the kind of error component, and then again you can plot, and then you can check the kind of best ones as per the a particular requirement. So, this is the graphical plotting. Here the a red mark line is the forecasted line and the black one is the kind of actual line. So, the difference by default will have actually the error component. So, now so the evaluating the performance of the forecasting techniques. So, we have several forecasting methods which we actually frequently use to do the particular forecasting. Of course, whatever methods we have discussed in this lectures are specifically relating to a one variable case, where you have a one variable and by default we are creating a additional variable with the actual data or the original data by introducing the lag variable. So, you can create n number of lag variables while validating the particular process, and then we have to check we have to choose which one is the best as per the particular requirement. So, likewise, there are some other methods through which you can actually do the analysis and then have the estimated model, then check whether the estimated is perfectly fit by deriving the error component, then use time series indicators like mean error, mean square error, root mean square error, mean absolute deviation, mean absolute percentage error. So, that means these are the typical time series indicators through which we can check the reliability of the model, stability of the model, and then we come to the conclusion that this is the model through which you can do the predictions, do the forecastings, and as per the as per the particular engineering requirement, and that too in a kind of decision making process. There are certain other models are there which can also add value to this particular selection process, which we will discuss in the next lectures. With this we will stop here. Thank you very much.